All right, so what if, what are the properties of y is equal to a to the x, when a is less than 1 but greater than 0? In other words, a is positive and a is positive but is less than 1, a is a fraction. So a could be something like, let us say, a half. And then this would be like y is equal to, let us say, a half raised to the power x. How would this graph look? Well, a sketch of the graph is given below. And you'll notice that the graph is similar. The graph of y is equal to a to the x to the minus x, where a is greater than 1, is similar to the graph of y is equal to a to the x, where a is what? Less than 1 but greater than 0. So the graph of y is equal to a to the minus x, where a is greater than 1, is similar in shape to the graph of y is equal to a to the x, where a is between 0 and 1. Again, the graph, sorry, so the domain are all the values of x. The range is values of y greater than 0. The graph does not cut the x-axis. Y is equal to 0 is a horizontal axis as x approaches positive infinity. A to the x is a decreasing function and is 1 to 1. The graph of y is smooth and continuous. So this is something that you guys should definitely investigate. Maybe use actual numbers to see if you can get an appreciation, a mental appreciation of it, so that if you're asked to do a sketch, you would know what to do. All right, here is an example. Example 29 is asking us to sketch the graph of y is equal to e to the x. Now, first of all, e, I think, is a positive number, which is approximately 2.718, I think. So in other words, the graph of y is equal to e to the x is the same as the graph of y is equal to a to the x, where a is greater than 1. So this graph would look probably something like this. Just doing a very quick sketch. This is my y-axis. This is my x-axis. Origin, y is equal to e to the x. Of course, this is always 1. The graph always cuts the y-axis at 1. That's what the graph of y is equal to e to the x would look like, because e is a positive real number greater than 1. And the graph of y is equal to e to the minus x is similar to this graph, but it's almost like it's a reflection of the other graph in the line in the y-axis. So the other graph would look something like this. Y-axis, x-axis, again, this is 1, the origin, and this is y is equal to e to the minus x. Moving on. In this example, we're asked to, using the graph of y is equal to e to the x, we're to sketch the graph of y is equal to 2e to the x plus 3. All right, well, the graph of y is equal to 2e to the x. Let's say I'm putting that in blue. The graph of y is equal to 2e to the x would look something like this. It's going to cut the y-axis at 2. All right. And so this would be the graph of y is equal to 2e to the x. Now, the graph of y is equal to 2e to the x plus 3 is essentially the same graph, but that would push the graph 3 units up. So this would be the line y is equal to 3. So it's the same graph, but it's going to go 3 units up. So the horizontal asymptote is now going to be y is equal to 3, and it's going to cut the graph at 5. So essentially, it's the same graph. I probably should change the color. Let's change the color. All right. So this would be the graph of y is equal to 2e to the x plus 3. All right. So the graph of y is equal to 2e to the x is similar to the graph of y is equal to e to the x. Essentially, for the same value of x, the value of y is going to be multiplied by 2. Now, the graph of y is equal to e to the x plus 3 is the same as the graph of y is equal to 2e to the x, but it has been translated 3 units vertically upwards. It's as if we just push the graph 3 units vertically upwards. Of course, we could view these 3 graphs using GeoGebra so that we can have an appreciation of what they would look like. And in how the 3 graphs would differ, how they would look the same. All right, so let's see what's next. All right, and this is probably the last example in this section. We're asked to sketch the graph of theta is equal to 20 plus 10e to the minus a half t. All right, if we're going to sketch that graph, we're just doing a quick sketch. First of all right, let us say that this is my horizontal axis. Let's say I'm going up by what? 10, 20, 30, 40, 50. Values of t are greater than 0. So values of t are greater than 0. But so I could start greater than or equal to 0. I could start with t being equal to 0. If t is equal to 0, first of all, it's the negative, good. So if t is equal to 0, so the fact that it's minus a half t, it's going to come that direction. When t is equal to 0, e to the minus a half t would be 1, and so the graph is going to cut the y-axis at 30. It's coming from this direction, but this part of the graph does not exist. The asymptote would be 20. All right. Let's make the asymptote solid. The asymptote is going to be 20. So this is the line y is equal to 20, and the graph comes like this. All right, this is my theta axis. This is the t-axis. This part of the graph does not exist because we are doing values of t starting from t to 0. So from t greater than or equal to 0. And this would be the graph of theta is equal to 20. The asymptote is 20 plus 10 e to the minus a half t. So this would be a sketch of the graph, what the graph would look like.